I'd like to thank everybody for coming. I believe there's questions at the end, and I'd be more than happy to answer them if we run out of time and we don't get to your questions. I'll leave contact information, and you can either contact me by email or by phone. Just as a brief overview, this is all about the AIAG VDA FMEA Handbook. When it first came out, I believe we all believed it would become an industry standard rather quickly. What we want to start off first with is what is the status of it becoming an industry standard? The measure of that is customer-specific requirements. The bottom line is the IATF 16949 does not require anybody to use any type of FMEA. What leads you to having to use a particular type of FMEA is a customer-specific requirement. So if we want to understand where we're at with respect to adoption of this as a standard, we have to look at the CSRs. Once we look at those CSRs, hate to bust the bubble, but we're going to find out that it hasn't become a standard yet. And so we're going to get into, I'm just going to do a real quick, but it's going to be reasonably detailed overview of the AIAG VDA method, starting off with its origin, because that is very important in terms of understanding it. We're going to talk about the role of software in the method. And then we're going to go through the D FMEA and the P FMEA, and also for those of you who don't have software but are using Excel, we're going to talk about using this method with Excel and what you run into. And then finally, we're going to talk about some of the problems you run into when you use the AIAG VDA D FMEA and P FMEA and how you can get around them. And then we'll summarize and open it up for questions. Back when the manual came out in June of 2019, Automotive Industry Action Group came out with a blog on December 11, 2019. And you can see here that these are just the companies I looked up that currently have CSRs. So in the blog, BMW, Stellantis, FCA US was specified. They basically come out and said that they believe that it could be used for future programs sourced after December 2019. So they thought they'd start using it. Ford Motor Company, as you can see here, said could be required to use the handbook on a per program basis with future programs with either the 2022 model year or commodities requiring functional safety focus. GM thought they'd start using it in 2023. Honda came out and said that could be required to use it as soon as February 1st, 2022, and that they expected that all their documents would be done this way by 2027. And the ones that I have not mentioned in the blog, I didn't talk about them. When we jump ahead to today, or actually this week, I went and I grabbed the latest CSRs. And if you pull BMWs, they don't say anything about the AIAG VDA handbook at all. You talk about Stellantis, they are the only one that I found that strongly recommended the use of the method. In fact, they say if you want to use a different type, and this is Stellantis Group PSA, if you want to use a different type, then you have to contact them. FCA, these two regions here, not mentioned. FCA US, okay. They say it may be used, but they actually prefer that you use the 2008 AIG 4th edition FMEA methodology, which I thought was pretty interesting. Ford Motor Company said they'll accept it, but it's not required anywhere. GM doesn't even talk about it. Mercedes-Benz doesn't talk about it. Honda doesn't talk about it. And Volkswagen doesn't talk about it. So I think it's pretty safe to say when you look at this particular matrix, this has not been adopted as a standard. And what I want to do now is I want to start talking about what the manual is, what the method is. And I've been doing FMEAs for 34, 35 years. I actually wrote several articles about what I thought were weaknesses of this method. And I predicted actually back in when the first version came out and we were actually able to review it. At that point, I thought it would never be adopted as a standard. And so we're going to talk about some of those things. We were all told that the AIAG VDA was supposed to be a harmonization of the U.S. methodologies and the European methodology. But if you actually, when they first came out with the, which I thought was great, they gave us an opportunity to review it. In that, for the first version we could review, they said the FMEA method is described by a planning and preparation activity followed by a 6-step process. This is similar to the previous 5-step FMEA process in the VDA volume for 2012. This 2012 version of the VDA FMEA manual was the first revision of the 1996 version, which is really what the methodology is based on. It actually goes back to 1988. We're going to talk about that. I actually, based on this particular, when we got a chance to review it, I had a paper published in Quality Digest, and it was called The Case Against the AIAG VDA FMEA, where I highlighted the weaknesses of it, how it doesn't work, the major problems, and it had to be changed. What was interesting is Mike Bucala, who was a member of the committee, this is his comment. He says, your article concludes that the team should have started with the XL-based AIG 4th edition methods, and by inference expected the Europeans to modify their software-based methods to conform to it. This is an unrealistic expectation. So the bottom line is, in his emotional reaction, he was telling you, everybody, what was going on. The bottom line is Europe had this software-based method, and it was going to be adopted. And you're going to see there's a reason for it, and that reason, I believe, is the AIG wanted to get into the software business. So here's a little bit of the background of how we came to the manual. So this goes way back to 1988, where Siemens contracted with a gentleman named Peter Rosenbach. You can actually call him the father of the method, to develop a diagnostic system with fault tree analysis for semiconductor. So he created this software prototype called Object FMEA. And inside this Object FMEA, it gave birth to the VDA method. And the bottom line is he created a fault tree program, but they called it FMEA. And fault tree doesn't equal FMEA. So this fundamental flaw, or this fundamental belief of FMEA equals fault tree, started back in 88. So in 89, Mercedes-Benz got involved with Siemens, BMW, and they got with Rosenbach's company, and they sold a contract to further develop the Object FMEA software. And after, 89 to 92, the first version came out and was offered for sale, was APIS IQ FMEA 2.0. And actually, Daimler-Benz Inner Services, it's a servicing arm of Daimler, the part of Daimler, they actually distributed the software. So you had an automotive company distributing FMEA software. So at this time, the manual hadn't been written on the methodology that this software covered. And that first manual came out in 1996, and that's his VDA Workgroup 131. Now, its manual closely matched the APIS IQ FMEA. One of the members of the committee was Jürgen Eilers. He was the manager director at APIS. And he actually said today's APIS IQ FMEA software was developed as part of the discussion accompanying the project. Many people, when that first version came out, they said that the manual looked like a user's manual for APIS IQ FMEA. Now, what's interesting is that Volkswagen did not want Mercedes controlling something as powerful as the FMEA. So they did not want, basically, FMEAs were critical to them. So they literally got with a company called Plato AG. It's Plato Skill, those of you who are familiar with it, signed a contract with them. And so that is why today the two largest players in the FMEA software business in Europe are APIS IQ FMEA and Plato AG. So this 96 got converted to 2012. And this 2012, if you want to understand, where the bulk of the manual came from of the 2019 AIG VDA FMEA, it's this manual, and this manual is based on this software. So 2016, AIG comes out and they announce that they're going to get into the software business. And they say, we're going to develop a software to support the release of the new AIG VDA FMEA manual. Now, what was interesting is in the initial draft, they said, when products and processes are complex, it's recommended that a specialized software be used to apply this method. With the time, depending on what article or blog you read coming out of AIG, they were saying that anywhere 75, 80% of all the automotive companies were using Excel. And so basically they're telling all those people, you're not going to be able to use this method with Excel. Well, they had to go into a fast backpedaling. So during multiple webinars, they attempted to roll back their statement. So they, we want to be clear that we have tested, validated with suppliers, and the method can be executed. Well, can it be executed? Yes, but with unbelievable difficulty. So the bottom line is that at the heart and soul of the AIAG VDA FMEA method found in the handbook is software. So if you want to understand the method, you begin by understanding the software and how it works, and it's based on fault trees. So the first thing we're going to talk about is the design FMEA. So in the methodology, you're going to basically, first thing they have you do is create the structure analysis, which is nothing more than a bill of materials. So you start at the top, you name your assembly, your sub-assemblies, your components. And then for each of those components, you can identify, say, a component characteristic. So this may be this could be some type of component, and down here in the component characteristic may be the material thickness. So you build this structure tree, and then after you build that structure tree, what you do is for each of these, you identify the functions. You build what they call function. Some people call it a function net, function analysis, function tree. Bottom line is you build this list of functions. So for the assembly, you identify all its functions. For the sub-assembly, all its functions. For its components, its functions. And for the components, the characteristics and the specs. And you link these together in the tree. So now we have this assembly tree, and now we have a function tree that is linked together. So we can go function to function to function. Then the next step is the failure tree. So we take each of these functions, we identify how we can fail to meet them. And again, we link these. So now we have basically a fault tree. We have a start at the top, and then we have this listing of how the assembly could fail, and then how the sub-assembly could cause the assembly to fail, how the components could cause the sub-assemblies to fail, and down at the bottom, how we could have incorrectly specified individual specs to cause the components to fail. So bottom line is we have what I call the VDA software product fault tree. So how that gets to FMEAs is this. So here's our fault tree, assembly, sub-assembly function. You have what we call the focus element. Now, it's very important to understand that the software needs 3 levels, and that's why you see assembly, sub-assembly, and component here. So in this case here, we're going to do the design FMEA on the focus element, which in this case, we're going to do the sub-assembly. So you take the function and put it in this column. You take the name of the component in this column. You take its function, you put it in this column. You take how it can fail to meet the column, you put it in this column. Now, to get the effects, you go up 1 level and grab the failure mode. So you basically say, when I fail to meet this failure, the effect is the assembly is going to fail. And so you see that we go up 1 level to get the effects. If we want to get the cause, we go down 1 level. So how did the assembly fail to meet the function? We answer that by answering the question, how the component failed to meet the function. So we basically just transfer these elements into the FMEA form, and the yellow pieces are the pieces we as users have to add in an attempt to turn this fault tree into a FMEA. I wish I could see you and ask you if there were any questions, but I can't. So the bottom line is, so the FMEA methodology requires the creation of separate DFMEA and DVP for every unique element. And these are called elements. The assembly is called an element. Sub-assembly is called an element. Components are called an element. Okay, so we do FMEAs on these. So now if we take the whole thing, our assembly, our complete tree, what happens is we actually end up creating 3 different, so this one tree, because we had an assembly, a sub-assembly, and component, this means we have to end up with 3 different design FMEAs. So we have to have an assembly design FMEA, a sub-assembly design FMEA, and a component. We don't do it for characteristics. So we take this first one. So here's our assembly. Here's our function. We go to the next level, and here's how we fail to meet it. Now we can't go up a function, so we have to fill this one in. We identify the impact of the assembly failure. But then to get the cause, we go down a level, which says how the sub-assembly failed to meet the function. So that's how we create the initial start before we add the columns we have to add as FMEA users. This is what the software auto-generates inside the FMEA that you see coming out of your structure, your function, and your failure net. So we go to the next one. We go sub-assembly function. Well, the product is this sub-assembly. Its function is here. Its failure is here. If we want the effect, we go up one level, which is how the assembly failed to meet the function. And if we want the cause, we go down one level, which is how the component failed to meet the function. And there you have our second design FMEA that comes out of this tree. So now the final design FMEA that comes out of the tree is the component. So we have our component, we go across, okay? And now we go up one level to get the effect. So the effect of this is how the assembly failed to meet the function. But now we go down a level, and the cause of this is how the component might have been incorrectly specified. So we ended up with this component design FMEA. So that is how basically the software, after you go in and you're in your software and you're building this tree, the structure tree, the function tree, and the failure tree, that's how the software grabs this information and populates these core columns of the design FMEA. Now, what you then have to do, so what I did now is I moved away from these generic terms, and I actually created an example. Okay, now in the AIAG FMEA Handbook, I believe it was a window lift motor, and I've done many motors. My master's is in EE. Didn't want to get them saying I did copyright infringement or whatever, so I did a seat motor. And the reason I did it this way is so you guys could go and look at the manual, those of you who request to see these slides, and you can take them to the manual. You can compare them to see that I'm basically walking you through the manual. So in our case, our three elements, the top level element is going to be our seat motor. The next level is going to be our commutation system, and the next level is this brush card body, okay? And we'll just do the commutation system. So if we come down here, here's the commutation system. We take these three elements here, we put them here. We go up one level to get our effect. We go down one level to get our cause. And so, like I said, if you guys ask to get these and you want to take these and compare them to, and you have the AIG VDA FMEA Handbook, you can compare this. They're going to talk about a window lift motor. I'm talking about a seat motor here. So what's the problem? Well, the big problem is several key problems. And the first thing is when people are forced to write requirements for every subassembly, every assembly, subassembly, and component, they tend to write detailed requirements at this assembly level. But at this level here, they don't provide enough detail that you can verify. Like, you would never tell a motor designer that they just have to have a commutation system. There'd be important characteristics about that system, such as these are characteristics versus speed, such as commutation current, arc duration, residual current, and commutation period requirements. So this is way too generic for anybody to design to. So consequently, when you go to verify against it, your DV is going to be weak because you won't know what you're verifying against. Likewise, when we get down here to the brush card body, we don't talk about how much force has to be transferred. And so what you see, if you, and I've looked at, I won't say, I'd say close to 100 FMEAs created AIAG VDA method. I literally got a chance in 1996 to talk to one of the authors of the manual. And I was actually in France, and we went over it, and I go, this is never going to work. And all the weaknesses I'm showing you here today, I told the guy back in 96 it would never work. But by that time, they had already created their software, and this is a ship that had sailed, and now it's the standard in Europe, okay? So anyway, so the number one issue that you see is that when you look at the requirements column of the various design FMEAs that get created, there's insufficient detail in the requirement. And this is all about when you do a design FMEA, the purpose of the design is a big misunderstanding about design FMEAs, that the purpose of, because of its name, design failure mode effect analysis, everybody thinks it's about listing failure modes and assessing the impact of the effects. That's not what it's about. What it's about is assessing the ability of your design to meet these design requirements. This is a risk assessment of how good your design specs are at meeting these requirements. And if these requirements don't have enough detail to be verified, that FMEA is useless. This line of the FMEA right here, these two FMEAs, because of this lack of detail, totally useless, will do nothing for us. The next major issue you have is, sorry about that, is the cause column. The design FMEA is a risk assessment of the adequacy of the design specs in defining a design that will meet these requirements. Well, we already talked about the importance of having right to requirements. Well, then let's talk about the importance about having the spec. What happens in this method is, except for the very last where you're talking about component characteristics, you never actually put a root cause in here. You never actually put a spec. You just stick another failure mode. So in this case here, we're saying I have to meet this requirement. And what happened is I failed. And why did it fail? Well, because this failed. Well, thank you very much, but that doesn't tell me squat about the strength of my design specs. So the bottom line is, when you use the AIAG VDA methodology, the only true root cause specs that meet the requirements of a properly constructed design FMEA are those that are done against the component. So when you actually get to a spec. Now the issue we have here is, this is a good definition of a cause, but this requirement here is too generic. So in this case here, all three of these lines of this FMEA are useless for managing risk in this motor, okay? Some of the other things you run into is that not all design requirements are functions, and we believe there's 18 different types of requirements. And so they're not all easily translatable to lower level assembly components, for instance, things like resonant frequency or drive-by noise. I mean, resonant frequency, there's a bunch of stuff that gets involved in that, and you will go absolutely nuts if you try to get this and use subassembly and component requirements trying to link it to meeting a resonant frequency requirement. The other thing is, the engineer finds themselves, and this is a common complaint I hear, is that the engineers are being forced to define design requirements for things they never define a design requirement. And I use this as a simple example. None of us make cakes, but if we were to do a design FMEA on a cake, we would not go in for each of the components that make up the cake and define what's the function of the sugar, what's the function of the flour, okay? We know their function. What we're concerned about is how much sugar and how much flour. We know that we're trying to meet these cake performance. So we don't create these intermediate requirements. That's why this particular method is not only extremely weak in managing risk, it's extremely ineffective in that it makes the user do a lot of stuff they normally don't do as a designer. This method was not done to optimize FMEAs. It was done to implement a piece of software. You're required to do a design FMEA and function for every component you want to include a spec for. So let's say in your design FMEA, you want to talk, so you got to be resistant to vibration, and you want to talk about your screws loosening to vibration, and you want to say the reason was I specified a screw torque too low. Can't do that in one line in an AIAG VDA. You must first begin by defining a line for what's the function of a screw. And that is a total waste of time. So there's other lower level ones here. I could get into AP, which has major issues in the way they actually set up their ratings. But these three here and the previous two, when I wrote my paper, I felt were sufficient to basically lay the case that this should never become a standard, and to date it hasn't. So basically when you go to do your FMEA, they talk about this 6-step method. Well, step number 2 is to basically show the 3 levels, your first structure net. Okay, so all you're doing is taking the seat metal, the commutation system, and the brush card body, and you put that into structure. So this here is your structure net or structure tree. The next 3 columns is your function tree. This step 3, all you're doing is take the second row of this, and you're putting it in your level, your step 3. So this is when this is when you're using Excel. So you're taking the structure 2 is to capture the first level, step 3 is to capture the second level, and step 4 is to capture the third level. Now, the interesting thing about this is as you look at this chart, you'll notice these items in yellow. These items in yellow, if you were doing a design FMEA, these are the columns that actually have a purpose that you must have in them, or you cannot do a design FMEA correctly. But you'll see there's 4 other columns here that in order to do a proper design FMEA on the at a seat motor level, at the commutation system level, I don't need. So of these 9 columns, I'm being forced to populate 4 that serve no purpose in the design FMEA. Once we get those in, and actually what happens is the software is pre-populating those for you because of the trees, then we as users of the FMEA now must go in and fill out these remaining yellow sections that you see with blanks. So this is how you basically, those of you who are using Excel, and now I know Ford's come out and said you have to buy FMEA software, but those of you who haven't or whatever, this is actually how you translate those initial structure, function, and failure nets into a FMEA form. You move the structure net, step 2, function net, step 3, failure net, step 4, and then you go in and you fill in the rest of the columns, and this here is the recommended action area. And that is design FMEA. I wish I could ask you if you have any questions at this time, but I guess I can't. So we'll handle them after. So if you have any questions, write them down. What I want to talk about now is the FMEA methodology. The software requires you to create a 3-level structure net, function net, failure net, whether you're doing design FMEA or process FMEA. Now, in the process FMEA, you're only going to have 3 levels, okay? Design FMEA, you could actually have more levels, okay? So the top level of your structure net for your process FMEA is always going to be the name of the process path. The next level is going to be the process step. Now, those who've done process FMEAs before, this is typically the structure. That's the end of your structure. But the software, the method needs it now because the method is written to support the software. The software needs a 3rd level. And so they created that 3rd level by adding the 4M work element. So not only you used to be able to say process step is this person, is the purpose of the step, these are the failure modes, and these are the causes. Now you have to say process step, you now have to break it into 4M work elements, and then you can start talking about modes and causes, okay? So then what we do, so we have to say what's the overall function of the process path. We take each of the steps, what are their functions, and then we take the 4M work element. So we take this step, we break it into its 4M work elements, and we say what is the 4M work element function? What's the function of that element? And then the last tree we have to build is this failure net tree. And here we say how can we fail to meet the process path function? Here we say how can we fail to meet the step function? And here we say how do we fail to meet the element function? And we're going to learn that this is a big, big problem because by forcing us to do the FMEA in this way, you're going to find out it's impossible to do a process FEMA correctly. So what happens is, so here's our flow again, and very similar to our design FEMA, we take this focus element, we put it in the first column, we take the function, put it in the second, we take the failure, we put it in the third, we go up one level to get our effect, and we go down one level to get our cause. So here we see we're doing a center bearing press in. We have to meet a position requirement. The failure mode is the position's off. We do this wrong. The clearance is too small to assemble the shaft. And the reason we did this is the machine stopped before reaching the final position. Now, if we want to turn this into a PFEMA, all we do now is we add our columns. We add our severity, current detection, current controls, detection controls, PFMEA, P, and our action reactions and how we're going to improve it. Now, the interesting thing, and again, I note here that there's only one element, basically the elements in a PFEMA, you're only going to do elements on the process step. So your focus elements are always going to be a process step. Now, the two major weaknesses of the AIAG VDA PFEMA methodology, and that I believe is all of these, I believe, collectively have led to the non-adoption of this method, okay? The first one is non-root causes. And the reason you end up with non-root causes is the method tells you, we go back here, the method tells you to take the failure of how to meet the element function and stick it in the cause column. Well, the problem is when we're doing a PFEMA, we're not interested in how this process step failed to do what it was supposed to do. And let me get to the one that we have our actual example. Here's one, we have an actual example here. Okay, so we have this centered press. Yeah, sorry about that. I'm confusing you. I want to go back to this. So here we have our press. We have to position the bearing. Here's our failure mode, axial positions off. But now when we get to the 4M element, we ask the question, how did the 4M work element fail, not why? And in a FEMA, process FEMA, we need to ask why, because our goal is to prevent these particular failures. So what happens is, if when you're doing your PFEMA and you say that the job of the press is to press the bearing in, and you say the failure cause is it didn't press it in far enough, that's not a root cause. We need to know, why didn't it press it in far enough? Was there a condition change in the equipment? Was there a setting? Okay, so the PFEMA doesn't ask how did the equipment fail. The PFEMA asks why, and when you ask the why, you can come up with the prevention control. But because of this methodology, this use of a fault tree, the only thing you can put in here is a how, and you can't put a why. So when you go to do the prevention controls, you have no idea what to write. The other thing is the linkage of the DFEMA to the PFEMA. As I showed you before, oftentimes in the design FEMA, the cause column is a failure mode. But in a PFEMA, the cause column is never a failure mode. It's always some spec in how we missed it. And if you go to the original AIAG VDA 4th edition, and I can prove this, I actually invented the concept of linking design FEMA to process FEMA in 1990. We kept it a secret for about 18 years. But the bottom line is that processes fail by building out a spec product, and designs fail because people set specs wrong. So if you don't drive to a spec, you cannot link your PFEMAs to design FEMAs, okay, which is very critical for many reasons. One is to get the risk right, because the people making the product are not experts in the purpose of a spec. They're experts in how to meet the spec. And also it takes away this very powerful capability of rapidly researching field failures. So the fundamental two weaknesses of the PFMEA method is the AIAG VDA method drives to non-root causes by asking you how the four element failed, not why. And number two, because you now have all these multiple design FMEAs that you're trying to link to one process FMEA. And in many cases, those design FMEAs have failure modes in a failure cause column. It's impossible to link them. Now, if you do have Excel and your customer you use Excel and your customer is forcing you to use the AIAG VDA method and they want to see their PFMEAs in those forms, this is how you do it. You basically build the tree the way I showed. You know, here's our three elements of the seat motor assembly line that leads to the center bearing press that leads to the press machine. Structure analysis step 2, just like it was in the design FMEA, is our structure net. So here you see your seat motor assembly line, your bearing press, and your press. Function analysis step 3 is the function net, just like in the design FMEA. So we come over here and we grab the 2-second levels and we populate these 3 columns. And then the last one is the failures. We grab the last one, which in this clearance is too small, axial position is not reached, and it's not in the pull until the defined pull position. We put those at the 3 level. Again, like we saw in the design FMEA, where we're being asked for information that are not needed to do the process FMEA, we realize we're being asked for 4 pieces of information that have no function whatsoever in a risk analysis of the process. So this is additional work, makes this process less efficient. Once we get these 3 steps built by merely transferring this across, all we have to do now is add our columns, our rating columns, our current prevention and detection controls, and our optimization. And here we have our PFMEA. So those of you who are using Excel and who are thinking about, using Excel to do the AIAG VDA method because maybe you're being told you have to do it, this is what you do. This is how you transfer these columns. And then you're going to have to add these columns here that I have to have populated in your spreadsheets. Now we've gone through this and we've shown you major issues with the DFMEA side of the method. We showed you major issues with the PFMEA side. Now, what do we do? How do we mitigate these weaknesses? So what do we do? Well, the most important thing to remember is that when you're doing FMEAs, the most important thing is you're creating design FMEAs and PFMEAs that are effective for managing your design and manufacturing risk. You do not want to create FMEAs for the sake of paper. Before I entered this business, my last job was a Ford plant manager. And the reason I left that job to pursue the implementation of FMEAs was at Ford Steel Division. I ran the last 17 operations in the coal mills. We didn't do FMEAs. For many years I was there and I was named plant manager and we made our customers do them. Then all of a sudden I got called into a meeting and said, you got to do PFMEAs. I'm like, okay, what's the PFMEA? What's the process FMEA? Now, I didn't get to become plant manager at 32 by not getting things done. It was like, show me what this thing is. Well, at that time, the book was 8 pages long. And I came to the conclusion that the method was not being done correctly. And so I came up with the way I thought they should be done. And after 9 months, now I had a large facility, 17 operations, 700 people. But after 9 months, we were saving on average every week $144,000 a week. And we do scrap and rework. And I wanted to tell everybody how cool FMEAs were and how excited I was about them. And they looked at me like I was absolutely nuts. And I go, wow, there's a lot of people out there just creating paper and they have no idea what the power could be. So the bottom line is this has to be your main goal. The second thing is you can't ignore the fact that these methods have fundamental flaws. And if you exactly follow that manual the way it tells you to do design FMEAs, the way it tells you to be, build those structure, function, and failure nets, you will create FMEAs that are ineffective for managing risk. But the neat thing is the methodology through the scoping area gives you sufficient flexibility. And the bottom line is you can scope the definition to populate the FMEA form in such a way that you can create a good FMEA, and the auditors will never know you're not really using the method. Because bottom line is my experience, and since this came out, and actually even since I've been working with the VDA method, the 96, I've had European clients who would use that starting in 96. So I've been involved in this method for 20 some years now. We had to get good FMEAs out, but we had to give them in their format. And so there's a possible way, we're going to talk about it in a minute or so, of how you can change the scope a little bit and create good FMEAs, give them the format they want. Your customer's happy, you're happy because you got good FMEAs, they're happy because you got the form. Now, I want to put a caveat out there. I'm not recommending you use this method. I think it's both ineffective and inefficient. But if your customer says, I want these in this format, you got to give it to them in those format. And so I say here, the important thing is the auditor is going to audit the compliance of your DFMEA and PFMEA output format with the AIAG VDA format and not the process you use to get there. So you're able to give them the format they want, but the way you fill it out is just going to be a little bit different. So if we look at, we say, okay, let's say I'm a guy I got Excel and I'm doing my FMEAs in Excel. Well, how do I turn my Excels? What do I have to add? What do I have to change? Okay, well, your headings are going to change, but you have this information you see here. You already have this, what I have in green. It's already in your FMEA. Now, what you got to add is these 4 other pieces. Now, there's 2 ways to add them. One is manually. Another way is to do it automatically. We've actually, I'm not allowed to sell anything. I will just say we've created a method we call it the Easy AIAG VDA method, where we kind of guide our users for a couple of simple entries, and they just hit a button and they can switch between the 2. But you can do this manually. You just have to really, really think about it. Likewise, so this is design FMEA. Likewise, on the process side, you can see everything but those 4 useless columns that when I talked about the method and before, I said they make you do 4 things you don't have to do. Well, those are the only 4 things you haven't already done. If you're already following the AIG 4th edition FMEA methodology, you've done all those methods. You've done all these requirements. You just haven't done these 4 additions that aren't used in the risk management process, but you're going to have to populate these. And again, you can either do it manually or you can do it automatically, okay? Now, very important. Now, what we're talking about here is we're saying you have your Excel spreadsheets. You have this, you did your data entry in a spreadsheet or maybe existing software, whatever, but it's done into the AIG 4th edition format. Very, very important, okay? You're not using trees. Just by adding some additional columns, you can get effective DFMEAs and PFMEAs in the AIGD format. So you just have to add columns. This is a very possible thing for you to do. If, however, you have software that is creating the 4th edition format from structure trees, function trees, and failure trees, you will find out upon audit, close looking at these are not created correctly. They will have the issues that we showed, failure modes in the cause column, and lack of enough detail in the requirements column, not root causes in the PFMEA. So what I'm telling you here is, if you've done this and you've done this in this edition, 4th edition FMEA method, by simply adding 4 columns, either in the DFMEA or PFMEA, you can move to the required AIG VDA format. If, however, the method of entry you're using software and you're using trees, you can't get properly constructed 4th edition. I can't say you can't get it. You got to be really, 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 really good. I've never seen it done to get to here. So in summary, the DFMEA and PFMEA methodologies contained in the AIAG VDA FMEA manual are fundamentally flawed processes that, if followed exactly per the letter of the law in those manuals, they are both inefficient and ineffective for the management of risk. Because of this, it's highly unlikely the AIAG VDA manual will ever become the automotive industry standard unless significant changes are made. However, significant changes to the current AIAG FMEA handbook methods are unlikely due to the link to the software-driven 5-step process originated in 1988 and first published in 1996. The cost of these software changes would be considerable. And the bottom line is, all the FMEAs that have previously been done, people would have to come to the difficult conclusion that they're not done correctly. Unless you have single component products and simple processes, Excel is going to be difficult to use, but you can use it. If you have multiple component products and you try to do, you can obviously do AIAG 4th edition very well, very easily. But when you go to do the translation and you add those additional 4 columns, you're going to have considerable difficulty. So if you have to comply with the AIAG VDA handbook because your customer demands that you follow it and also want effective FMEAs, you have a unique challenge. You must create a FMEA output that is sufficiently compliant with the handbook to pass an audit while not using the methodologies to the letter. You can't get to good FMEAs using them to the letter, but it can be done. So with that, Dave, I'll turn it over to you for questions if there are any.
Yep, thanks, Rich. We got a couple of questions here. Okay. First question that came up was, can you hear me okay?
Oh, just for anybody who wants the slides, here's my contact info. I'll just leave this up so you guys can write it down. Send me an email. I'll send you the slides.
Thanks, Rich. You can hear me okay?
Yeah, I can hear you.
Okay, so a couple of questions that came up. How many levels of physical subassembly are supported? That was a question early in the presentation.
In terms of the DFMEA, it's infinite. In terms of the PFMEA, it's always going to be 3 levels.
So another, this one, it says requirement can be captured in a separate column in the same way as the AIAG form. They are needed, whichever method is used. Slides. Oh. There was a comment. Yep, there was a comment that said absolute right. Drill down to root causes with why. Otherwise, you can't come up with countermeasures in the prevention column. And then someone put a comment and said actually it is possible to enter root causes in the cause field. They're not linked with another system element.
Okay, so to that, if you want to finish is that done, or I'll wait till you finish the question? There's
no. Catch it while you got it fresh in your mind.
Okay, so the bottom line is okay. So, let's take these one at a time because you gave me 4 questions. Give me the first point. The first thing you said.
One of them was a comment about the requirement.
Oh, the function and requirement. Yes, they allow you to write a requirement, but it's the function that drives the action. Okay. So if you look, there's no requirement entry in the failure net. There's a failure, there's a function, and there's no requirement entry in the failure net. There's a function entry, and then there's failure entries. Those failure entries are written against the function. They're not written against the requirement. So yes, it allows you to put that detail there, but all that detail is useless because the method doesn't use it. Okay, what was the next question?
There's a comment and probably has a question loaded. Actually, it is possible to generate output in the 4th edition format from the analysis done using the tree structures, but you can see causes coming from other components or subassemblies. These are easily identified by the part name and number in the field.
No, the issue is not can I generate a process FMEA or a design FMEA in the 4th edition FMEA format. The question is, is what ends up in the cause column. Okay, and what ends up in the requirements column. In the cause column of your design FEMA created in the AIAG 4th edition format, if you create that FEMA using the structure, function, and failure nets, you're going to stick failure modes in that cause column, and that line of the design FEMA is going to be useless. On the process side, the failure cause you're putting in is going to be an answer to how the 4M element failed. It's not going to be an answer to why did the 4M element fail. So whoever wrote that question is absolutely accurate in saying, can I create the form? Yeah, you can create the form, but now instead of having a root cause in the cause column of the PFEMA, you're going to have a how and not a why. You'll have no idea what the prevention controls are going to be, and that PFEMA will be of little or no value. So I did not say you could not create the forms. What I'm saying is if you try to generate an AIG 4th edition, either process FEMA or design FEMA, and you create that using the structure, function, and failure nets, you're going to bring across the same sins that exist when you generate these things in the AIG VDA format. They don't go away. It's not a question of creating a form. It's a question of, am I creating a FEMA that is effective, a design FEMA and process FEMA that's effective in managing risk? And I'm telling you, if you use structure, function, and failure nets to drive those in a 4th edition method, the answer is no, you are not creating FEMAs that are effective in managing risk.
Thanks, Rich. There was a question here that says, did the AIG VDA Handbook allow for tailoring to define a company's specific procedure?
It doesn't matter. What you're stuck with is this is why I do this presentation. I say you must begin by understanding the software. You know, the comment about, if I go way back to slide 1, Mr. Bucola's statement, he said, your article concludes that the team should have started with Excel-based 4th edition methods and expected the Europeans to modify their software-based methods, okay? This isn't a handbook. This isn't something that somebody wrote down that people are trying to follow, okay? This, if you use AIG VDA base, this method is based on software. And so fundamentally, unless you change the underlying software, unless all the Europeans are willing to say, you know, that VDA software we use, it leads to non-root causes, we can't use it, it ain't going to change. So the bottom line is this methodology is not a method to optimize FEMAs. It's a method to implement a particular software. I actually wrote an article in Quality Digest. I forget the title. I've written several articles. I talk about what I thought the AIG and VDA should have done, what they should have done to harmonize the two methods. And I recommend go to Quality Digest, look up my name. You'll see, I don't remember what the name is. It might even be what they should have done. I forget the title. But I explained, see, because basically what happened was, it was like if we were building a car factory, we would not build the factory and then decide what kind of car we're going to build. Well, the way the VDA method got started is they had a piece of software and they wrote the manual to match the software. And that's the well-known fact in 1996, when this software first came out, not this software, but the software that led to this one, people complained. They said, this is a software manual, you know? Anyway, there's the answer.
So it hasn't showed up as a question here or questions, but probably we're talking about estimates. Normally when we use the AIG version 4, we can get a reasonable thumbnail guess at how many hours it's going to take to actually do one. What, any comments on that, Rich, as to how this expands that?
Yeah. Since I've never sat side by someone to go through the complete pain, I can only tell you that I can tell you what I believe, what we see all the time. So, for instance, like, it is not uncommon, like using the method that I wish they had in this manual versus this structure tree and all this. Okay, just a good basic method. Okay, P-theme is the easiest to estimate. Okay, let's say you have a complex piece of equipment by like a CNC machine, maybe 50, 60 failure modes. We can typically do that process step in about 3 hours. Less complex piece of equipment, say like a reheat oven, you're looking at an hour to 90 minutes. And typically manual processing steps, you're looking 20, 25 minutes. On the design side, it depends on the number of components, okay, how complex it is. And really, when we teach these, we both teach a class, we just teach you the concepts, or we teach a workshop. And when we quote a workshop, we tell you we're going to give you a deliverable. We're going to do that FEMA you have to hand in. And they will give us, we say, send us your requirements and send us the current bill of materials, because the design FEMA is a risk assessment of the adequacy of a design and meeting a set of requirements. And not that length's important, but our FEMAs are normally going to end up between 150 to maybe 250, maybe 250 pages on a reasonably moderately complex product, and we'll do that in 4 to 5 days. So that's what you can do. As far as giving you a number of how long it would take to do that same FEMA, first of all, you couldn't do it. But if you tried to do it, I couldn't even put a guess on it. I wouldn't want to do it.
Thanks, Rich. Probably the other question that would be related to this would be, in the AIAG version 4 approach, we would start the design for you. Probably have a process guy sitting in there. And
yes.
That would be an effective way to do that. Are you seeing that this is still able to achieve that end? Or
absolutely. One of the most, okay, so we believe there's 18, one of the big problems with FEMA is you got to go back to Mill Standard 16. I'm having a senior moment now, but anyway, it's the godfather of all these, okay? And again, there was a concentration on failure modes and effects, all right? Ask you a question again. I just lost my train of thought.
This is relationship and timing of the process FMEA following design FMEA and interaction between the two.
No, you asked something else, didn't you?
Well, it was the idea of having the process guy in the design FMEA.
Oh, yeah. So anyway, whenever you do a design FEMA, we believe there's 18 different requirements you have to consider. One of those is function. So when one of the first changes that I implemented as a forward plant manager, okay, was the change of the name of the first column and from function to requirements. And one of those 18 requirements is designed for manufacturability. And it's my personal belief that before you release a design for manufacture, you should bring what we tell them is and it doesn't take long. You can get this done in about 2 hours. We bring manufacturing in and we show them the design. And the rules we give the design engineer is they're not allowed to argue. They're not allowed to defend their design. All they're allowed to do is write. And what we simply ask the people who have to make the product is to tell us, and we tell them, we're expecting you to make this many in this amount of time. Here's the design. What is it about this design? And we call this category design for manufacturability. We say to them, what is it about this design that'll prevent that from happening? And they say, oh, you haven't given enough space here, this tolerance is too tight or whatever, okay? And all we do is we write them down. And then we go and we put those so we got a requirement that we have to meet this productivity. And the reason we don't meet it is all their complaints. And then we put the causes in, and we actually do V. In some cases, it's a design review. Some cases, it's a prototype build. And we actually confirm whether or not their complaint was good or bad. And the really cool thing was the first time we ever used this, and this was way back, I think in 1993 or 1994, it was in Monroe Stamping Plant. They had a sensor, and they were always being asked to position it near an elbow, and they couldn't hold that position. And we were going through this session, and we go to the manufacturing people, and they go, what is it? Oh, the HEGO sensor. They go, what's about this design that drives you nuts? They go, that darn HEGO sensor. They go, we cannot hold that tolerance. And the designer goes, well, what do you need? And he gave him a number, and he goes, God, we can give you twice that. It doesn't have to be there. And the guy says, we've been fighting this for 5 years, and that's all I had to do was tell you, you know? So we believe everybody should add this 18th category to their first column of the design theme that says function and requirements. You know, obviously, this doesn't fit design for manufacturability. We believe that will save you a lot of money by adding that one requirement to the list of requirements you're designing to.
Great. Thanks for that, Rich. I see we're about 5 minutes over. We've got 124 people online yet. I don't see any more questions popping up. Last chance for a question. If you want to type one in.
Yeah, and if anybody has any questions, feel free. You have I'll put my contact info back up. You can email it to me.
And just as a reminder, if you want to copy the slides, you contact Rich directly. Well, no more questions coming up, Rich. So on behalf of the ASQRRD, I'd like to thank you. And also on behalf of our audience, I'd like to thank you for a great presentation. Hope you'll come back and revisit this topic with us again as we see it evolve.
Sounds great. I enjoy them. I enjoy these conversations. I guess it's one way, but I enjoy I love teaching this method. I mean, I've devoted 30 years of it sounds crazy, but almost 30 years of my life to FEMA. So.
Well, it's probably the most valuable tool that we have, or probably the one that's used most often, if not. Thanks again, Rich. We'll end it here.
All right, everybody have a great day. Thank you very much for your time.